So there are 4 types of primary tissue, right? So we have connective tissue, which we're going to talk about today in today's anatomy. We have epithelial tissue, muscle tissue, and nervous tissue. Now, I believe you'll go through each of these types of tissues throughout your anatomy, whether it be, in histology or in some sort of lecture. There are tissues outside of this, like I believe your actual organ tissue, which we call parenchyma, that doesn't fall under any of these sort of categories, but these are like the main types of tissues. So if you just think about like your skin, for example, you have like your epithelial tissue, which is the outer layer. Then you've got some connective tissue under that, which actually makes up the bulk of the skin. And then connective tissue includes things like bone as well. And then obviously we've got muscle tissue, and in the skin, or in the arm, sorry, that allows you to move. And then nervous tissue, like the nerves actually innervate the muscles and tell them when to contract and stop contracting. So you can pretty much break like most of the tissue in like your arm or your leg, right, into these 4 categories. And connective tissue really encompasses a lot of different structures, right? So we have 3 main structures, so 3 main categories. So we have loose, or we call it areolar connective tissue. We have dense connective tissue, and we have other connective tissue, right? So loose connective tissue are stuff like fat. Fat connects stuff. We often can see fat. It's one of the layers of the skin called a subcutaneous layer. Lamina propria is in certain different sites on the body. You have your epithelium, and under the epithelium is this connective tissue layer called the lamina propria. You might see that in the airways, for example. So your epithelium, which contacts the sort of outside, if you may, although like the epithelium or fluids from outside, or air even from outside. So like the cells lining your gut are epithelial. And then deep to that, you have this lamina propria. And you'll learn more about that later on. The dense connective tissue, and we'll talk about what loose and dense actually means, but dense connective tissue is tendons, so like how muscles insert on specific structures, ligaments, which join bones together. So tendons join muscle and bone, ligaments join bone and bone. Joint capsules, so every joint is surrounded by this connective tissue called a capsule, and you have fluid in that, and that just helps with infections, keeps them out. Then we have the dermis, which is the main layer of your skin. And then other types of connective tissue include cartilage, which is going to be one of the main focuses today, bone, which is another main focus, and blood, right? So pretty much anything that isn't epithelium, nerves, muscle, or actual organ tissue is connective tissue, right? I should also just say it's just me today, because I believe the lectures for this week were predominantly like the HKS, HEP, health and human behavior ones. So any questions, I'll get to them and answer them. Okay, so when we're thinking about connective tissue, what's the function of connective tissue? Well, support. Support's pretty key, right? When we get punched, not that it should happen often, but we don't want everything to flop around and cave in. We need something to actually support the skin, to keep things firm and keep things in place. So support is pretty key. Connection, obviously it's in the name, and separation, right? So it can be detrimental if you had, something like bone touching the epithelium of the skin. Like if you had a 1-cell layer between, the air and bone inside, that's going to lead to problems. So support, connection, separation. And really, I think in med, like rather than getting 3 things like this and memorizing that, I think it's important, like what you could do is just like figure out why all those make sense to you. And you might write them down and you might memorize them, but if they all make sense to you, that's going to help, because like on your exam, if you get like a multiple choice question on this, which you probably won't, 90% sure, then you can just go through the answers and say which ones make sense, and likely the one with like the least reasoning or the one that doesn't make sense is the answer. So And just from personal experience, like I don't remember a whole lot of stuff from year one. And especially if you go into real like detail with like what you know, what you revise, it's harder to remember. But the stuff that has logic to it makes the most sense. So that's something to keep in mind. So we know that the function of connective tissue is support, connection, and separation. What's it actually made out of? So we have cells, obviously, specialized cells now connective tissue, and outside the cells is what we call an extracellular matrix, or ECM. Okay, that consists of fibers, we can talk about their role, and ground substance. So common fibers that you may have heard of already are collagen, elastin, and reticular fibers. Ground substance is like a gel-like substance containing proteoglycans, glycosaminoglycans, and glycoproteins. I mean, really, like, this is not so important. Just know it's got specialized cells and extracellular matrix, which is intuitive. And this is what I was talking about before with this top picture on the top right. That's the lamina propria. So we have your epithelium, which lies in the basement membrane, and your lamina propria is often the layer beneath that. So what are the specialized cells that you find in connective tissue? Well, the role of these cells are to actually produce the extracellular matrix. So depending on the type of connective tissue, we might need to be really firm and strong, or we might need to be flexible. So your specialized cells will produce their extracellular matrix that caters to those needs. They come from mesoderm, from mesenchyme stem cells, and they differentiate into specialized cells. You might have heard these words like ectoderm, endoderm, mesoderm. They seem to like come up a bit, although no one will actually tell you what they mean. From memory, they were like in a couple of past exam questions, so you might run into them. Just as like a general rule, like ectoderm is your like skin and nerves. Endoderm is like your gut, the gut tube and your lungs, and mesoderm is everything else. So mesoderm is like your heart, your bone, heart, bone, muscles, all of that stuff is mesoderm, right? So ectoderm is ecto meaning maybe outside skin, and obviously what innervates skin, like or what lies just on the skin, it's nerves. So skin and nerves is ectoderm. Endoderm is like the most inside, lungs, gut. It's not organs because your heart is mesoderm, and so endoderm is literally just like that, like esophagus, liver, stomach, all that sort of stuff, intestines, and your lungs as well. And the rest is mesoderm, right? So now you don't even have to know it's mesoderm. It's a given, right? Because it's not skin, nerves, gut, or lungs. Okay. And so these specialized cells, which come from mesoderm, they're pretty like the endings of the words can be used to figure out like what they do, right? So we have chondroblasts, which make the extracellular matrix in cartilage and differentiate into chondrocytes. We have osteoblasts, which do the same in bone, lipoblasts, which become adipocytes in adipose tissue or fatty tissue, and we have fibroblasts. Okay, so the ending blasts means it's immature, so undifferentiated, and it secretes cellular matrix, so it secretes fibers, right? And another thing you might want to like pair is just like the prefixes to what they actually do. So chondro is associated with like cartilage. And one trick I use to memorize stuff in med is just comparing the actual, like the first letter almost sometimes. So chondrocytes, cartilage. So when you see the C's, then you can compare those. I actually used this quite a bit. For example, like there's a part of your brain called the pneumotaxic center, and that like stops you from inspiring. So the way I remember that is like pneumotaxic prevents inspiration, and like they both start with P, right? So pneumotaxic prevents, and the other one that encourages is the apneustic. So pneumotaxic prevents. So the main takeaway is like you can use the first letters of words to help you remember them. That's something I do. Osteo, you might have heard with bone, like osteoporosis, it's a bone condition. Osteoarthritis, bone condition. So osteo means like relating to bone. So osteoblasts become osteocytes. Adipose tissue, you might know, but lipo is like fat. Lipase digests fat. And these fibroblasts are an important cell. So they make fibers, right? So fibro, like blasts, as in they secrete stuff, and then fibers as in from the fiber. So there are ways to, remember that. So we have our mesenchymal stem cell, and they differentiate into these different types of cells. Okay, so blast is immature, cytes is mature, and they maintain the structure. Okay, so those are the specialized cells. They sit in an extracellular matrix, right? And so there's a few main fibers in this matrix. Collagen and elastin are very common. I'd say they're probably worthwhile knowing. Reticular fibers don't really stress. But collagen, you see it pretty much everywhere. Like it's the most common, I think, protein in mammals. Yes, it is. So collagen is strong, flexible, and resists stretch. There's like collagen pretty much everywhere. But it's, strong, flexible, resists stretch, and elastin, it's in the name, gives some elasticity. So you can use this to think like in areas of connective tissue which need to be a bit more flexible and a bit less sturdy, you'll probably get more elastin, less collagen. Whereas in ones where you need to be really strong and robust, you'll get more collagen, less elastin. And reticular fibers just give support. Okay, so there are a few types of collagen. Again, like I don't think this is super high yield, but it might be worthwhile knowing. Possible you'll get an exam question on this, but not super high yield. So there's 4 types. Type 1 you get in tendons, capsules, and bone. Type 2 is in cartilage. Type 3 is in reticular fibers, and type 4 is in basement membrane. You'll cover those types more in depth in your actual like lecture/workshop. And so maybe just note the emphasis that the lecture places on that. And then we also have ground substance, which we talked about before here. This is like our gel-like substance, which everything pretty much sits in. That can hold nutrients and waste, which move by diffusion, so moving like by concentration gradients from high concentration to low concentration, and it provides some like mechanical support as well. So everything's not like floating around and knocking into each other. Okay, so if you can recall from the start, we talked about loose connective tissue or areolar connective tissue. We talked about dense connective tissue, and we talked about other, right? So loose connective tissue is flexible and deformable. It has lots of ground substance and loose fibers, right? So that's this type here. So it doesn't have any sort of like specific structured arrangement. It all looks a little bit random. Then we get dense connective tissue, which is inflexible and strong. And it has many fibers and few cells. So that dense connective tissue up here, that looks a lot more organized, looks a lot more robust, right? It's not just random like areolar tissue. So we can have regular dense connective tissue where fibers are arranged in parallel, and that gives you strength in one direction. So like tendons, ligaments, you want strength in a certain number of directions, right? Like with your bicep, if all your fibers run one way, that gives you, more contraction force in that direction. Then you can have irregular dense connective tissue. So still you have like lots of fibers, lots of strong fibers, but you have strength in many directions. For example, like your arteries have like a muscular wall around them. And in the connective tissue of your arteries, you need to be able to withstand forces from all directions. So it's better to have an irregular dense network of fibers than your regular, which you'll see in like tendons, ligaments. So here's what they look like on a histological level or a cellular level. So we have our loose connective tissue again, which is, as I mentioned, a little bit more random, a lot more ground substance, your gel-like substance, fewer collagen and elastic fibers, and you'll get this in your lamina propria. So you might want the loose connective tissue, less robust. Lamina propria like sits below your epithelium. You don't need that to be super strong. If anything, you want a bit of give. Regular dense connective tissue, again, it looks a little bit more organized. We see some sort of parallel fiber arrangements coming along here. And again, now it's very little gel-like substance, so we don't want a whole lot of give, but we have lots of collagen fibers which give us strength, and they can be arranged parallelly or orthogonally. And this will be seen in your tendons and your ligaments. And your irregular dense connective tissue, that again has very little ground substance. You have collagen fibers in bundles with random orientation, and that will form your capsules and your submucosae. So like if you think about it, dense connective tissue just has less ground substance, more fibers. You want regular dense connective tissue when you want forces in specific planes, specific directions. So that's like with tendons, which are at the end of muscles, and ligaments. Then you want irregular dense connective tissue when you have to withstand forces in any direction. So like your joint capsule, you want like protection on every side of the joint. Something like that is important. Okay, that's connective or loose and dense connective tissue. Now we'll talk about other connective tissue. And the main focus of today is really cartilage and bone. So cartilage, you might have heard a little bit about cartilage before. You have some cartilage on your nose, some cartilage in your ear. There's actually lots of cartilage in the body. But there's some key properties that you might want to take away. So it's solid and firm. And these cells, chondrocytes, C, chondro, and C in cartilage. Chondrocytes sit in lacunae, which are little holes, little pockets, surrounded by extracellular matrix. Cartilage is avascular and aneural, meaning there's no blood supply, no nerve supply. So that means the repair isn't as good. It takes time, right? So to actually repair, you need a good blood supply. And cartilage calcifies with age. So it grows in two different ways. We have appositional growth from the actual edge of the cartilage, so for here, and interstitial growth from the inside. So like if you make new cells here, then it will push the whole thing out. Again, if you're trying to memorize like interstitial from the inside, so stuff like that, it actually works a lot of the time, and you can often find a word for it. And we get three types of cartilage. So we have a hyaline cartilage, your elastic cartilage, and your fibrocartilage. And we'll talk about these three a bit more in the next couple of slides. I'd say like knowing just the basics about cartilage and the basics about these three types, that's probably one of the more important things that we'll talk about today. So I'd say that's on the high yield side, worthwhile knowing. So this stuff is probably worthwhile knowing. So we have three types of cartilage. We have hyaline cartilage, which is your most abundant type. You'll find that in your respiratory tract, ribs, and articular just means like your joint surfaces. And it's got a role in bone growth, and you'll learn about endochondral ossification. Then you have elastic cartilage, which is elastic fibers, and it's found in your external ear and your epiglottis, which is that flap that covers your trachea and your esophagus, or your esophagus. So if you like feel your if you feel your external ear, like that's really elastic, right? You can move that around everywhere. So that's a different type of cartilage than the one you want on your ribs, right? Or the one you want like lining your joints. Then we have fibrocartilage, which is actually like a really strong type of cartilage. So that's a combination of hyaline cartilage and dense fibrous tissue. So it's high tensile strength, fights strong forces, and this is the stuff you get like in your spine. So there's like discs. You may have heard like a herniated disc or a disc prolapse. You get these cartilage discs in your spine between the vertebrae, and they're fibrocartilage. You see them in your meniscus, which are like pads between the bones in your leg. So your knee joint has menisci in between the bones. You get them in scar tissue and tendinous insertions. So like elastic cartilage, is when you want something a little bit more floppy, like your epiglottis has to flop up and down. If you're eating, it has to flop over your trachea to close that off. So you want it to be elastic. External ear, like it's elastic. Fibrocartilage is when you need real resistance against strong forces, like in your spine, like in your knees. And hyaline cartilage is pretty much found everywhere else, right? So all cartilage is surrounded by a perichondrium. Peri meaning sort of outside of, either side of, except for fibrocartilage and your articular cartilage, which is a type of hyaline cartilage. Okay, so perichondrium is like just a layer that encases the cartilage. Peri meaning outside of. So this is what the different cartilage types look like, and really we can take, a leaf out of the book of connective loose and dense connective tissue to actually look at this, right? So when we spoke about loose connective tissue, it was like lots of fibers arranged randomly. And that's pretty much what you see in elastic cartilage. These little circles with dots are the cells. Fibrocartilage, remember that's like our dense, regular connective tissue. We want resistance against massive forces. So it has everything's got to be sort of arranged nicely and compactly. So you get dense layers of collagen, which is used for strength, and then you get more flattened and organized cell rolls. And then your hyaline cartilage, which is just a bit in between. So it's not quite super elasticy, and it's strong, but it's not as strong as you need in fibrocartilage. Okay. And on the right, you just see the different sort of types of the cells and different stain. But basically, like lacunae are little pockets that these cells sit in, right? And so we'll learn about that a little bit more. But basically, when it's a chondroblast, remember blasts, they secrete extracellular matrix. When it's a chondroblast, as it differentiates, like it's secreting all these extracellular matrix, it's secreting all these fibers, and eventually it gets sort of like stuck in the fibers, I guess, and then it becomes a chondrocyte, a mature cell, and it sits in these pockets called lacunae surrounded by extracellular matrix. That's cartilage, and now we're going to talk about bone. So unlike cartilage, bone has a rich neurovascular supply. The bone actually heals a lot faster than cartilage. Some cartilage injuries never heal, but bone, like fracture, might be 6 weeks, which is depends on your perspective, but pretty good in my opinion. So bone has a mineralized extracellular matrix which stores calcium and phosphorus. So you might have heard, like get your calcium up for your bones. The tissue is arranged in layers called lamellae, and the external surface of bone is covered by something called periosteum. So osteo meaning bone, peri meaning like around. We had perichondrium covering the cartilage. Now we have periosteum covering the bone. And the internal surfaces of bone are lined by endosteum. It's the same thing. Endo is like inside, like endothelium you might have heard of. That's the epithelium that lies into your blood vessels. Osteo meaning bone. Okay. And so mature bone is either classified as compact or spongy. Another word for spongy is trabecular. And this picture, probably worthwhile knowing, I think this is from lecture as well, but this actually came up on the exam. So, worthwhile knowing like where you'll find compact and spongy bone. The spongy bone is all of like this stuff on the inside. It looks like a little honeycomb arrangement of sort of different fibers or different like lines. All these lines are called your trabeculae. And then your compact bone is sort of the outside. So you can have a thick shell part and you can have a thin shell part, and that's just the initial outside strength. And then the inside's more of your support act. But everywhere has like this rich neurovascular supply. So, you can heal bone a lot quicker. So what's the difference between compact and spongy bone? Well, compact bone has a high percentage of extracellular matrix, and that allows it to have, really high strength and be used for protection. So that's what we want when, it's pretty much protecting the inside, where you have your bone marrow and things like that. Compact bone has these things called haversian systems, and these consist of concentric, meaning like circular lamellae, which are these sort of layers, and they run around longitudinal canals. So you have like blood vessels, and surrounding your blood vessels are these circular layers, and each sort of set of blood vessels and its accompanying layers are called an osteon, and they mostly run parallel to the bone's long axis. So that's always worth keeping in mind. So remember, as we go back here, the tissues, so the actual cells, extracellular matrix, that's just arranged in layers called lamellae. Contrast that to spongy bone. Here's an example of spongy bone where you have your trabeculae, are these sort of things here, and then your bone marrow is like here. So spongy bone stores your bone marrow and it resists compression. So actually having the fibers arranged like this it's actually good to have fibers that, or you know, lines in multiple directions, because that resists all forces in those directions. If all the lines sort of went one way, then a force like this might cause damage. But because we have, you know, forces or lines in every single direction, like a force like this is going to be blocked by, you know, some fibers with the right orientation. So that's the advantage of like a honeycomb-like structure. The layers of tissue, the lamellae, they don't form Haversian systems, but rather they're all organized into these lines, honeycomb-like lines called trabeculae, and your bone marrow is found between your trabeculae. Okay, so what cells are found in bone? Well, just as a general tip, like progenitor generally is like your sort of stem cell-like cell. So your osteoprogenitor cells are your precursors of bone. So they're the ones that will differentiate and become bone cells. So they will differentiate into osteoblasts, and you find them in the inner periosteum and endosteum. Once they differentiate into osteoblasts, your osteoblasts are your bone-forming cells. They deposit the bones. They deposit the, you know, the extracellular matrix, and they control the bone mineralization. Then they get sort of stuck in their little lacunae or little pockets, and they become osteocytes, which are mature bone cells located in these lacunae. Mature bone cells, so osteocytes, contact each other via canals called canaliculi, and they're little sort of passageways with things like blood vessels, which allow the diffusion of nutrients and oxygen, which feeds into the fact that I said before, like bone is really well vascularized and innervated. Then we have osteoclasts, and what you might think is like these three cell types all produce more cells. And if you can remember, actually the very first week that this PSP ran, I talked about something called apoptosis, controlled cell death. So if we're always producing new cells, like we're going to get too much cells sometimes, and it can be good to like trim back that number, or to have a method of getting rid of, you know, any cells where issues have happened. And that's where osteoclasts fit in. So remember, different ending now clasts instead of blasts. And these are like phagocytic bone cells. So they will pretty much like eat your bone cells. So you know, ingest them, break them up, turn them into little apoptotic bodies. And so they resorb bone during remodeling. So large multinucleated, they dissolve bone with acid, and they release breakdown enzymes. So really, like what's important here, I think just knowing the different types of bone cells is good. And then if you just have like a general idea of what they do. So osteoprogenitor cells are like the stem cells, they become osteoblasts, which, you know, form the bone. Then they differentiate into mature osteocytes, which sit in these lacunae. And then you have osteoclasts, which, you know, remodel bone and ensure that it doesn't overgrow. Okay, that's pretty much all for this week and this lecture. So hopefully you've taken away just some basics about cartilage, bone, and connective tissue. I will put these slides up onto the drive afterwards. And so, yeah, that's all for today. If you have any questions, feel free to let me know in the chat. If not, thanks very much for coming, guys. And I hope you've taken something away from today, and have a lovely week.